Everyone. Today we'll be talking about direct manipulation and immersive environments. We will look at the scope and the impact of this human-computer interaction, as well as the practical applications of it. So, what are the direct manipulation applications? So we have graphical user interface, embodied user interface, virtual reality, web page design, and mobile communication, and a couple of others. We will look at the standard elements of the graphical interface, which is based on direct manipulation. We'll look at the bitmap screen, the desktop metaphor, as well as what is called the WIMP, which stands for Windows, Icons, Menus, and Pointers. So those are major components of the graphical user interface. The standard elements of the graphical user interface, which are based on direct manipulation, would include this WIMP for Windows, as well as the desktop metaphor and the bitmap screen. What is a desktop metaphor? By metaphor, we mean relating to an object from the real world in order to create the user experience on the computer desktop. So, for example, the trash can or recycle bin is an example of a desktop metaphor. So, on our desktop, we have this little recycle bin or trash can that is in an analogy with the real world recycle bin or trash can. And that is where we place the objects, files, directories that we no longer need, that we want to get rid of. And that's a metaphor. So that's just an example of a real world analogy, what we mean by a metaphor. About the Windows icons, menus, and pointers. In terms of the windows, we can have multiple windows. That is, each application appears in a separate window where it can be moved on the screen, it can be maximized or minimized, or tiled. We can have those applications overlapping. Allows this kind of window is just a visualization of the running application. It allows us to move and resize the application and as well as to scroll the contents. The icon is a little expression of the application that can be placed on desktop or inside folders and directories, which allows us to select, highlight, or click or double click onto the application to open it and close it, as well as to move it from one directory into another. So the selection and activation of the icon is possible, of the application is possible through this icon. The icon can be static or animated, and again, it can use the desktop metaphor. So, for example, the icon of the recycle bin would look like an actual recycle bin trash can. That is a small trash can that can be moved around the desktop all through the folders and directories. Some of those icons are static, others could use an animation. So the icon is usually some graphic design representation of the application it is expressing. How about the menus? So the menus would allow us to pull down, usually from the top bar, sometimes from the left bar, and another times as a pop-up or contextual menu from an item. Like for example, if we right click on an icon, we could be able to look at the properties of the icon and other menu options. So the properties of the icon might include who created the file, let's say file attributes, who created the file, who's the owner of the file, what are permissions of the file, for example read, write and execute permissions, what was the last modified date of the file, when it was originally created, and so on. If we right click on it, we could see a menu with those options. Other menus exist usually on the top of applications, which allow us to open and close files with the application. If it is a network application, to establish network connections. If it is an application that processes music or video, to be able to open, play and stop those musics and video. So the options for the particular application allows through its interface can be accessed at the menu. So we have looked at Windows icons, menus, and now we look at pointers. So the pointer is what you see here on the screen, where I am moving with my mouse this little arrow. That's a pointer. The pointer can be an arrow or it can be just straight line, as for example when we type text and you see this cursor appearing in between the letters that they're typing. That's another pointer. Typically this pointer looks like an arrow that I'm showing right now that allows us to click on icons and window application windows and move them around the screen, arrange them, minimize them, maximize them, double click on them to start them, open them and close them, as well as delete them if we want to. So the pointer is a property of the dialog boxes, allows us to look at properties of dialog boxes, to check boxes and select radio buttons, as well as to fill in text if we want to type text or commands. So that is the WIMP, Windows icons, menus and pointers metaphor. Now we have another abbreviation which stands for WISIWYG. Now we will see what that means. Allows for multiple selection scopes, such as characters, word lines, and spaces. Allows us to move, copy, delete, and insert text, icons, files, as well as allows to select the style of our text. For example, the font, the color, the size, and whether it is bold or italic. That's what is being visible on the screen at that time. So direct manipulation can be done through the graphical user interface as well as there are other modalities that allow for direct manipulation in addition to the graphical interface that we described with the windows and icons and pointers. So there are other modalities such as touch screens and sensors, for example. So with the touch screen, instead of using the mouse pointer, we could use the sense of touch in order to press on the icons, double click on them, such as tapping them, closing them and opening them, as well as moving them around the screen through our touch. So this is commonly being used with smaller devices such as cell phones and iPads and certain computers that have a touch screen. So the touch allows for the haptic sense, pressure, and temperature to be used in order to manipulate the interface. There are other modalities as well, such as spatial inputs, like three-dimensional interaction, using the camera, such as face recognition, as well as some voice recognition. We could use also our voice to issue commands to the applications. This is commonly used in vehicles and cars because we don't want to be touching or pressing anything to while we are driving, because that could distract our attentions from the road and from driving. So commonly voice recognition is used to issue commands in the vehicles to the computer in the vehicles. There are also multimodal inputs. It is possible to click icons with our eyes and with facial movement. So we said the face recognition can be used. Oftentimes this is used for authentication. Let's say we want to log in to our computer or phone, or we want to lock computer or phone. We could use a face identification, Face ID, to lock and unlock the phone or the computer, but as well as to issue commands to the computer what to do, open and close applications and move them around. So the eye movement and the facial movement can be used as a form of input, as well as gestures. So the graphical user interface, in addition to the mouse and pointers and menus that we would normally click, there are other modalities that allow us to manipulate the interface of those applications. So let's look at an embodied user interface. There are certain wearable devices that we could wear on us, such as the Apple Watch, that would allow us to use the graphical interface in a virtual world and to wear the devices. So there are wearable and embodied interfaces. These are particularly applicable for portable computer devices like PDAs and Palm series of held hand devices. So there is design of this embodied user interface design allows for natural manipulation. So the hardware will sense and interpret manipulations, usually body movements and gestures, as well it might use the eye scan or the Face ID for authentication, as well as for issuing commands. So the body would be treated as part of the user interface. So, for example, the fonts have certain features where, let's say, we write a text and we no longer want to, we have made some mistake, we want to undo what we wrote. We could shake the font and it knows that it should undo what we just wrote. So if we just shake it, and menu would appear that says you want to undo what you just typed, and then you can click undo. So shaking, squeezing, tilting. For example, we want to change from portrait view to landscape view. We want to look at picture horizontally or vertically. We just tilt the phone from horizontal to vertical and vice versa, and it knows to rotate the picture and portrait or landscape orientation. So the device can be squeezed, shaken, tilted in order to manipulate the lexical elements of the interface. So I just gave an example with a cell phone and iPhone. Another example is the Xbox. The Xbook. So this is an electronic book. So electronic book or an audio book. It is more than a book. It is a digital book. It's like a book, but it's a digital book. It looks similar to the paper book, so it might be using some of those desktop icons and pointers, metaphors to make it look like a real book. In terms of its size and weight and usefulness, but it is more interactive and it's a digital book. Let's look at the design of this book. It is portable and graspable. It can be held, touched, and carried. It is designed to support a set of specific tasks that relate to the book reader. So we could open beginning, end of book, table of contents, scroll through the book, that is flip through the pages, as well as search and play audibly the contents. The work material are contained inside the devices, and the devices would embody the tasks that they're designed for. These kind of Xbook casing are physically designed to make the tasks easy and natural to do. So, the natural manipulation allows for integrating the physical body of the device with the virtual contents inside, as well as the graphical displays of the content. So, the body of the Xbook is treated as part of the user interface. So the user would be allowed to scroll through the menus by tilting the display. Also, there is a zoom feature possible. We could push, release, and stir the contents, as well as make them bigger or smaller. So what were the requirements when we designed this kind of interface for this digital book. The first requirement was to realize the digital device so it can compute, store, and as well as to be controlled by the user. We wanted to have a high quality display where two pages can be viewed and the display is in color. We also wanted to have the option to use a pen, so we would be able to highlight, circle, and underscore texts inside the book, so the user would be able to mark and annotate the book. And it would take voice commands as well, so we could talk to the book and tell it open yourself, close yourself, or go to a specific page. So also the book contents itself can be played as an audio book. So the stored content can be voiced to relieve from eyes from reading, line by line. So, in order to design, implement, and evaluate a device like this, we have to identify specific tasks such as turning the pages, annotating a document, searching, navigating, as well as indexing. The next thing we need to do is to identify the interface design. If we want to turn the pages, for example, how are we going to implement that? We want to allow the user to navigate through the multiple page documents by simply turning the pages. The user should be able to change the display pages on the device by using the natural world analogy or metaphor. How would we change the pages if it was an actual paper physical book? We would follow that analogy in the digital book, so we'll make it look like the physical book by visually showing the pages flipping from one side to another. Physical manipulation will be allowed in the user interface, but we would like to again have an effect that is similar to the natural world or to the physical effect of holding a standard paper book. So the task should be similar to the physical real-world book. The user would turn the next page with left or right flick. They could use the upper right corner of the page to turn to the previous page. Or if we want to go to the next one, they would use the left to right flick on the upper left corner. So let's look at the implementation. From hardware point of view, how would we do this turning of the pages? So we need the hardware to support the flick manipulations to detect finger pressure in the upper left and upper right corners, as well as to speak to the book and give audio commands. If we wanted to just say to the book, go to the next page, we could use a voice recognition to understand this command to flip the pages, in addition to the physical pressure such as touching the sensors, and be able to flip the pages in this way. And the evaluation, once the design is completed, we could thoroughly evaluate by using varieties of contexts in several contexts, and make the appropriate changes as necessary once the design has been evaluated. Now let's look at some virtual reality systems. Let's look at the introduction to the virtual reality systems and a variety of these systems. The virtual reality or virtual environment usually refers to a state where a level of interaction, autonomy, and feeling of presence is indistinguishable from the real world. So it is quite similar to the real world, but it is a computer system. So in this virtual reality system, the three factors are very important or common in the interaction styles. Sense of direct physical presence, sensory cues in 3 dimensions, and natural interaction. So what do we mean by the direct physical presence? So compelling sensory cues are created by the technology to give a user a strong subjective sense of physical presence and direct experience. So the cues might be visual, aural, haptic, which means sense of touch, as well as using wearable body interfaces. Visual would be using our sight to see things, and then as well as audible to hear sounds, or a combination of all of those. So this kind of sensory cues are used in 3 dimensions. The system would exploit the sense of sight, visualization, as well as sounds in order to audibly hear the system, and the sense of touch to be able to move, select, open or close items on the interface through touching them. At least one of these channels would be represented in 3 dimensions. So, the natural interaction of these virtual reality systems would allow the computer-generated objects to be manipulated using gestures similar to the real world. So, like I said, we can open and close items move them around, such as pick them up and turn them around. So these virtual realities are cost-effective solutions that would mimic the real world. I would use real-world metaphors. The virtual reality would have the capacity to take a user to an abstract and sometimes impossible environments. So the practical applications of these would be oftentimes, for example, in medical studies for medical students where they need to do certain surgeries, and we have then virtual patients that they can do the surgeries or the medical exams on, or dangerous environments such as firefighters in fire situations of fires where the firefighters need to go through some training. A virtual environment would be used for safety reasons. So the virtual world can be smaller or larger than its real world analogy. So it can be microscopic or macroscopic. So applications include a wide variety. Training and simulation, like I said, for medical students or firefighters, for example, but as well as many scientific applications, scientific visualizations and interaction. Also for engineering, design, and manufacturing, so manufacturing of cars or robots or aircrafts would oftentimes use these virtual realities. As we already mentioned, medical training and aerospace, and then some are used for architectural planning and operations in hazardous environments. So the virtual reality system is used to create a most realistic experience, for example, for a firefighter or a pilot. The controls of their craft would be displayed and will be taken from the same production line that are used to create the real controls on those aircrafts or firefighter devices. The windows are replaced by high-resolution computer displays, and then the sounds are choreographed to give the impression of the real-world experience, such as the fires or the starting and switching off of the aircraft engines, as well as the movements of those environments. So hydraulic jacks and suspension systems would give feeling of vibration and tilting, such as climbing and turning in the natural world experience. So they will mimic those environments, those real world environments in a very well. The virtual reality system would create a realistic experience for the firefighters or pilots that we used as an example. It is a cost-effective virtual analogy of the real-world situation. Like we said, it's used for hazardous environments as well as for risky environments such as medical applications and medical exams and surgeries. So the benefits of this environment is that it is safer, it is more useful for training purposes, and there are no specialized skills needed to use it. so it can be used for beginners or common users. The costs can depend on the applications, but high performance virtual reality systems can be expensive because of the computational resources as well as the high resolution peripherals that are required for the interface with the humans into the virtual environment. So we have looked at direct manipulation systems and virtual environments.